Yeah, I have shared a screen to you. Is it visible?
Yes, sir.
Okay, okay. Okay, class. In the previous class, we have discussed about the divide and conquer approach. Today, we will discuss about the greedy techniques. In the divide and conquer approach, we have divided the problem into sub-problems, and then we have find out the solution of each sub-problem. After that, we have conquered the each sub-solution to find out a complete solution. Okay. Now, it's greedy approach, greedy techniques. As you can see that, as name suggests, that greedy technique, it means it will always select for your optimal solution. Okay. So greedy algorithm or greedy technique, it always looks for the best option, the solution that looks best at a moment, that is selected every time. This is a optimization solving problems. It always follow your local optimal choice at every stage, at each stage, instead of finding the global optimum. The optimization problem is the problem which needs the best solution among all the possible solutions. In every state, it will select the best solution, the optimal solution, which is the best. For example, suppose uh, you want to travel from one location to another locations, and there are different modes to travel. You can travel from through bike, car, train, plane to complete the journey. But the problem is the which is the best mode to determine to complete that journey. So this is an optimization problem. For example, suppose you want to move from A to B, and there are three ways from moving A to B, and every route have a weight with concern route. Then you will select the best path for traveling from location A to location B. You will cover the journey with minimum cost. Then this optimization problem is called your minimization problem. Every time you select your best path, best selection, to select your minimum cost every time for traveling from one location to another locations. It especially focus on your minimum cost. What should be the minimum cost? Or it can be that maximum profit. In every stage, it will look for the maximum profit. It will also focus on your minimum cost. What should be the minimum cost? And what are the risks in this solution? It will also look for the minimum risk. Suppose there is example. Suppose consider the scenario of a job recruitment process. During that job interview, there are different rounds. Like you have written round, you have technical and HR round to select the best candidate. Now, one possible approach is To do so, it's allow every candidate to appear in each round and to select the best candidate. First approach. Allow each or every candidate to appear in each round and select the best candidate. There may be one solution for that. But this approach is very time consuming. Another approach is just filter out some candidates at each round based on some criteria. Then select the one who clears the last round. This would be your less time consuming process. So the idea behind this greedy approach is to select the currently best solution among all the given set of solutions based on some criteria. This is your greedy approach. In place of to allow every candidate to appear in each round to select the best candidate, you have selected another approach in which in every round you have filtered some students, you have filtered some candidates. In every round you have filtered some candidates, and after among these some candidates you have find out the best candidate after your final round. So this could be the best approach to select a best candidate among a group of students. So this approach can be called your greedy approach, greedy technique. There are some applications of your greedy approach, greedy techniques. These are your knapsack problems, your job sequencing problem, minimum spanning tree, optimal merge pattern, Huffman coding, or Dijkstra's algorithm. We will discuss one by one these algorithms. First application is your knapsack problem. In greedy approach, the knapsack problem is also called your fractional knapsack problem, because knapsack problem is also solved through your dynamic problem, your dynamic programming. But the problem which we solve through your greedy techniques, that is also called your fractional knapsack problem. And another problem is 0-1 knapsack problem. But in the greedy technique, the first application is your knapsack problem. So the fractional knapsack problem is also one technique which are used to solve the knapsack problem. Knapsack is a bag, a container which has some capacity to store the value, to store the item. So knapsack is a container. So in fractional knapsack, the items are broken in order to maximize the profit. I want to maximize the profit, or the cost should be minimum and the risk will be very minimum. So the problem in which we break the item is known as fractional knapsack problem, because we break the items if knapsack has a minimum capacity. But in 0-1 knapsack problem, either we have to take complete object or otherwise we have to completely leave it. Okay. So this knapsack problem can be solved with the help of using your two techniques. First is your brute force techniques, brute force approach. That is also called your hit and trial method, brute force approach. The brute force approach tries all the possible solution. That try all the possible solution with all the different fractions. But it is very time consuming approach. As we discussed in the greedy example, in the interview procedure, the first procedure that is brute force approach, because it tries all the possible solutions. Second approach would be your greedy approach. In the greedy approach, we calculate the ratio of profit and weight. We calculate the ratio according to the profit or according to the weight, the ratio of profit and weight. Accordingly, we will select the item. The item with the highest ratio will be selected first. Okay, in the numerical exam, you can also understand it. So the basic approaches to solve the problems are, the first approach is to select the item that is based on your maximum profit. The item must be the maximum profit. And the second approach should be to select the item based on your minimum weight. Or the third should be to calculate the ratio of your profit and weight. We will discuss it through example. Here you can see, here there are three objects: object 1, object 2, and object 3. You can see in the screen there are three objects: objects 1, object 2, and object 3. The profit of object 1 is 25. The profit of object 2 is 24. And the profit of object 3 is 15. Accordingly, the weight of object 1 is 18, weight of object 2 is your 15, and the weight of object 3 is your 10. This is a problem. And in this problem, the knapsack capacity is 20. Knapsack is the bag or container that can store maximum your 20. The capacity is 20. It can be your kilogram, it can be anything. The maximum capacity is 20 of the knapsack problem. Okay. So first approach, the case first. What should be the first case? The first case would be that we are greedy about the profit. In this problem, you can see that the profit of object 1 is 25, object 2 is 24, object 3 is 15. In the first case, we are greedy about the profit. Then you can see that in all these objects, which object have highest profit? Because we are greedy about the profit, we want the maximum profit. Then you can see that object 1 have your highest profit, that is your 25, and remaining to 24 and 15. So object 1 have your 25 profit. Then we will put this object in the knapsack. At first we will put it in the object knapsack. The knapsack capacity is your 20, maximum 20, but the weight of object 1 is 18. Now we will put object 1 here. So the weight 18 is here. Still we have two quantity because the maximum capacity is 20, and still we have two quantity to store. So 25, we have put first object, that is 25, the profit is 25, plus now we will check which have next profit or maximum profit. 25 object 1 is already in the knapsack. Then we will check in object 2 and object 3. Then you can see that object 2 have maximum profit in both objects, object 2 and object 3. In object 2, the profit is 24. So we will select object 2. But the knapsack quantity, the knapsack is only 2. In the knapsack, we can store only 2 value. But we have total 15 value. So how much profit will be calculated? So it will be measured with 2 divided by 15. That is the portion, multiply with the profit, that is 24. If we calculate this will be calculated at 25 plus 48 divided by 15. That will be 25 plus 3 by 2, that will be 28.2. Is it your optimal solution? In the first case, we have checked about the profit. Now, in the first case, we are greedy about the profit. So when we are greedy about the profit, we have find out that the solution is your 28.2. The maximum profit is our 28.2 in the first case. When we are greedy about the profit, then how can we say that this is our optimal solution? No, this is our not optimal solution. Now we will check the case 2, second case. In the second case, we can see that now in the second case, we are greedy about weight. Now we are greedy about the weight. If we are greedy about the weight, we want that there should be minimum weight, in the knapsack. Why? Because we want that in the knapsack of capacity 20, we can store more number of items, because we are checking here the minimum weight. We are greedy about the weight. So we will check about the minimum weight. So that is same object 1, 2 and 3. In the first, there is profit 25, 24 and 15. And the concerned weight is 18, 15 and 10. Now we are thinking about which have our minimum weight. Which have our minimum weight every time. Okay. Here you can see that in all the three objects, object 1, 2 and 3, object 3 have minimum weight. Object 3 have minimum weight, that is your 10. That is your 10. And the profit with this object is 15. So we will put this object 3 in the knapsack. In the knapsack, object 3 is taken. So concerned weight with this object is 15. And the remaining space in the knapsack is now 10. Now we can also put 10 value in the knapsack. Now we will check for next minimum weight. Next minimum weight is your 15. Okay. And the profit, the profit with this weight is, that is your 24. That is your object 2. Now we will put object 2 in the knapsack. And the profit will be 20 divided by 15. 20, the portion is 20, 10 upon 15. 10 upon 15 we have, because we can put 10 more value in the knapsack. So 10 divided by 15, that is the fraction, and divide into multiply by 24. That is the profit part. So that if we calculate this, then we have find out that the maximum profit with this case is 31. In the previous case, if we are greedy about the profit, then the maximum profit is 28.2. And in the second case, now we are greedy about the weight. Then we can see that the maximum profit is 31. Is it optimal solution? Now we will check the third case. Now we are greedy about both. That is the approach. In the greedy approach, we calculate the ratio of profit and weight. And accordingly, we will select the item on the ratio of your profit and weight. After calculating the ratio, you will find out that what is the maximum profit. In this case, in the third case, the objects are same, the profit is same, the weight is also same. Then we have find out the ratio, profit and weight ratio. Profit and weight ratio. Then you can see that the ratio of profit and weight, that is your 1.3 in the first case. That is your 1.3 in the first case. In the second case, the object and weight ratio, that is 1.6, and in the third case, that is 1.5. Profit and weight. Profit divided by weight. We have divided the profit with weight. We have find out the ratio. That is 1.3 in the object first case. In object 2 it is 1.6 and in object 3 it is 1.5. Now we will check about the ratio of profit and weight. Now at this case we are greedy about both. We are greedy about profit and we are greedy about weight. We are greedy about both. So you will check that. So the knapsack capacity is your 20. And we can see that in all these three objects, 1.6 is the maximum value. That is the maximum value. That is the maximum ratio. In this case, we are greedy about the ratio. So that have the maximum value. So in the knapsack, we will put the object 2. We will put object 2. Object 2 have 15 weight. So the quantity 15 is stored in the knapsack. Now we have total 5 remaining value. 5 more space in the knapsack. The object 2 have 24 profits. So 24 is here because we have put total object 2 in the knapsack plus we have 5 remaining space. In the next case, in the next iteration, we will check that 1.5 is next maximum, next level. So we have put the value of object 3 in the knapsack. Only 5 value because we have only 5 remaining space. So the net profit will be 5 divided by 10 into 15. So after calculating this, we will check that now the profit is 31.5. In case first, when we are greedy about the profit, then the maximum profit value is 28.2. And when we are completely greedy about weight, then you can see that the maximum profit value, that is your 31. And when we are greedy about both the profit and weight ratio, then you can see that the maximum profit is 31.5. Okay, is it clear to you? We have discussed all the three cases. Okay.
Yes, sir.
Okay, in the all three cases, now you can check that in which case, which is the best solution. Yes, you tell me that. What is the best solution?
Third case.
It's a case 3. That is the greedy approach. In case 3, when we calculate the ratio of profit and weight, and accordingly we will select the item, we have selected the item with the highest ratio will be selected first. So that is your best case. That is your greedy approach. So third one is that is the your greedy approach. Okay. Is it clear?
Yes.
Okay. Yes. Okay. Now, if we talk about the complexity of greedy, okay, greedy. Uh, I will discuss about where knapsacks. Okay, through the help of some program. Okay, I'm sharing you one screen. With that screen, I will discuss the complexity. Knapsack. Is it visible screen? I think is it visible? Okay.
Okay, sir.
Okay.
So
This is a program. Okay. This is a knapsack program Now here we are calculating the time complexity of this knapsack problem, this fractional knapsack problem. Here is the main function. You can see the main function. Okay. In the main function, first one is int w equal to 50. It will take your constant time because we are storing a variable. So it will take your constant time, order of one time. Next, these are the items. We have three items. So it will also take your constant time. It is an array that will also take your constant time. Okay. So this will take your constant time. Now, this is your structure part. Okay. It will take your maximum n time because we are assigning the value and assigning the profit in the structure that is size of n. So it will take maximum your n of time. Okay. According to knapsack problem, here we have find out the profit and weight ratio. Profit and weight ratio. Profit and weight, profit and weight. Now it have compared that which one have higher value. It means both values are compared. Okay, in this case, so it will take your linear time. Okay, so main part is here. This will decide your total knapsack problem. Okay, here you can see that here is a for loop, and every time you are comparing the weight, it means you are arranging the value in your descending order. Okay, you are arranging the value in your descending order. If you are arranging the value in your descending order, what should be the complexity? Can anyone tell me what should be the best complexity if you are ascending in the decreasing order? Because every time it is taking the maximum profit. What should be the maximum complexity?
Log in.
Yeah, that should be your n into log n. Okay, that should be your all n log n, because if you are using our merge sort in the divide and conquer approach, that should be the n log n. So the total complexity of this knapsack problem will be order of 1, that is taking constant time for constant values for storing variables, order of n time for inserting the values, for putting the weight and items, and it is take n plus log n time. So total complexity that will be calculated as, I'm showing you with paint in one knapsack problem. For other problem, I will not discuss like this. Okay. Is any screen is visible to you? Paint screen. Okay. Here,
Yes.
so the time complexity will be, it is taking your order of one time, constant time for storing the value. Okay, for storing all the values, and it is taking linear time for assigning the items and the weighted to all the objects, and it is taking order of n into log n time for arranging all the weighted in a decreasing order. So the total complexity of this knapsack problem will be an order of n into log n, because in algorithm we take the maximum of all these things, because the maximum is your order of n log n. So the complexity of knapsack problem will be your order of n into log n. Okay, that should be your
Yes.
order of log n. Now I am sharing a screen now. Is it visible?
No.
No, sir.
Okay, wait a second. Now visible?
Yes.
Okay. So it is clear, the knapsack problem, the fractional knapsack problem. Okay. Every
Yes.
time. Okay, very good. Every time we will go for the best solution in the knapsack problem. The second problem is your Huffman coding problem. The second greedy techniques problem, application of greedy technique, that is your Huffman coding. Okay. So Huffman coding is your lossless data compression algorithm where you use decoding. If you want to decode your message, then you use Huffman coding algorithms. The idea is to be assign variable length codes to input characters, all the input characters. And length is assigned codes on the basis of the frequency of the characters. Okay. So this technique is used to compress the data to reduce the size without losing any of the details, because I want to decode it. So it was first developed by David Huffman. On the name of David Huffman, this is known as Huffman coding. So generally it is useful to compress the data in which there are frequently occurring characters, and the variable length codes are assigned to input characters. These codes are prefix codes. Means the codes are assigned in such a way that the code is assigned to one character. That is not the prefix code assigned to. So there are mainly two parts to major parts in Huffman coding algorithms. In the first part, we build a Huffman tree. We build a Huffman tree for all the input characters. And in the next part, we traverse the Huffman tree and assign codes to the characters. Okay. In the first part, we build a tree. And in the next part, we assign the codes to the characters in the Huffman coding. It will be more clear with the help of this numerical, with the help of this example, Huffman coding. Here, there are 5 characters: A, B, C, D, E, or F. These are the characters. Okay. The value of A is 50, B is 10, C is 30, D is 5, E is 3, and F is 2. And we have 100 characters. M, that is 100 characters. Okay. That is A is 50, B is 10, 30, 3, 2, 5. That is the maximum time it is present in the data. How many times it is occurrence in the data. Okay. That is the concerned weight with these characters. A 50, B 10, C 30, D 5, F 2, E 3, and F is 2. And the characters are 100. Okay. Suppose if we use our ASCII values, ASCII encoding, in the ASCII value, we have 128 symbols to represent a character. Okay, that is 0 to 127. It means it takes your 7 bit to represent 128 symbols from 0000 7 times 0 to 7 times 1. The maximum value of 7 times 1 is 127. If we use ASCII value, because ASCII values are also used to encode. For example, A is representative to 67. The ASCII value of every character has the ASCII value, because computer cannot understand these symbols. It wants some codes, it wants some signals, and these signals are represented in the binary form, in the form of bits. So ASCII value that takes your 128 symbols, that represents 0 to 127, that takes 7 bit. 7 bit it takes to represent a single character. So 7 bit it takes to represent a single character. So for 100 characters, for there are total 100 characters in the message. So how many bit it will take? It will take 7 into 100. It means 700 bits to encode the complete message. For encoding a message of 100 character, ASCII value, ASCII case, we use total 700 bits for encoding. In the first case, is it optimal? Now we will check for another case. Suppose we have only 1, 2, 3, 4, 5, 6. We have only total 6 characters, A to F. So there are total 6 characters in our message. So 6 characters can be represented in 3 bits. That will be your 000. Suppose A is represented with 000, B 001, C 010, D. Every is unique. So 6 character can be represented with the help of 3 bit. A single character A is represented with 3 bit, B is 3 bit, C 3 bit, D 3 bit. So a character use 3 bit to represent, to encode. So total 100 characters will take your 3 into 100, 300 bits. In the first case, if we use ASCII encoding, then we have taken 7 bits. So total 700 bits are used for encoding. In the second case, if we use only 3 bit, because we have 5 words, 5 characters in different occurrence time, and 5 characters can be represented with the help of 3 bit. So maximum number of bits are required, 300 bits to represent. Now we will check with the help of your Huffman coding. So in the Huffman coding, the first part is build a Huffman tree for input characters. We have 5 input characters, A, B, C, D, E, and F. We will make a Huffman tree. How we will make a Huffman tree? For making a Huffman tree, every time we will select for 2 minimum. First 2 minimum. These are your 5 characters A, B, C, D, and E. You check that whose 2 characters have minimum value. Here you can see that E and F, these have minimum value. E has 3 and F has 2. So first we will consider these two, E and F. And every time we will consider the left value always in the left side. Sorry, the minimum value in the left side. But that is not compulsory. You can do in the reverse order, but every time you do the same thing. Okay, I am taking one value in the the minimum value in the left hand side and the maximum value in the right hand side. If the value is equal to that value, then I will consider in the left hand side. Okay, this is assumption. So first I have take first two minimum. First two minimums are E and F. The value of E is 3 and F is 2. The minimum value is 2. So I will put 2 here. The F. This is F. Because the minimum value is 2 and E is in the right hand side, the value is 3. Okay. Now I will combine these two. I will sum up these two. F and E. The value is 2 and 3. The value, the summation of these two is 5. 5 is here. Now I will put this value 5 here. Now 5 is compared with other characters 3 E and F that are already discarded, that are already done. Now we will check the value 5 with other values. Now 5 is here one value and we will check that which two are minimum. 5 is one minimum. They will check next minimum that is also 5. That is D. D is 5. So the value are same. 5 and the value of D is same. But I am putting, if the value is same, we are putting it on the left hand side. Now we will put at the same level D is 5. Now we will sum these two values 5 and 5. This is your 10. 10 is put here. Now we will compare this value 10 with the remaining value. Remainings are your A, B and C. Now we can also see that the value of B is equal to this value. So we will put B here in the left hand side. Now we sum these two values, that is your 20. Now we will compare this 20 value to the remaining. Remainings are your A and C. But you can see that the value is minimum is 30. But 30 is you are greater than 20. Now we will put the C on the right hand side. That is 30. 30 and 20, 30 plus 20, that is 50. Now we will compare this 50 value with the remaining one. There is only one character left. That is A, and the value is 50. They both have same value, A and A. Now we will sum these two, that is 100. And we have total 100 characters. The value is here 100. Okay. Now for assigning the value, first we have make a Huffman tree. This is your Huffman tree. This is your Huffman tree. Okay. Now I'm assigning, I'm traversing the Huffman tree and assigning the code to each character. There are 6 characters and I'm assigning the code on the basis of this Huffman tree. How will I assign? I will assign from the root. From the root, how much time, how much characters, how much bits I take to traverse to that location. For example, you can see that to to traverse the node A, this is A, this is A. To traversing to A, I have to move only one bit, that is 100 to 0. With the help of 0 bit, I can traverse node A. I will traverse. So to represent A, I require only one bit, that is 0. That is 0. If the value, if the character is on the left side, I will put 0. If the value is on the right hand side, I will put 1. In the tree, you can see that on the left hand side it is 0, 50 is right hand side, it is 1. Now from 50, 20 is on the left hand side, we will put 0, right hand side is C, we will put 1. Now from 20, left hand side is B, we will put 0, right hand side it will be 1. From 10, I will also compare from D, it is 0. From 5, it will be 1. Now from 5, I will compare. Left hand side is F, if I will put here 0, and in E, I will put here 1. With the help of this tree, I will check that how many bits are required to traverse to that character. For A, it requires only one bit. Now for B, where is B? B is here. B is here. So for traversing B, for reaching B, I have to go from 1, 0, 0. 1, then 0, and then 0. So we required 3 bits to represent the character B. And for C, C is here. For C, we require 1 and 1, only 2 bit. For C, we require 1 and 1, only 2 bit. And for D we require how many bits? 1, 0, 1, 0. We require 4 bit for D. And for E, we require E is here. We require 1, 0, 1, 1, 1. We require total 5 bit to represent E. And same as F. For F, we require 1, 0, 1, 1, 0. It also require your 5 bit to represent the character F. Okay, and you can see that every character they have a unique number of bits, for every character. Okay, so total how many bits are required? So for A there are 50 recurrences and it requires only 1 bit. So total it requires 50 bits for A. For B, the occurrences is 10 times and every time it requires 3 bit. So it will take maximum 30 bits to represent. For C, it and maximum occurrence time is 30. So it will take 30 into 2, 60 bits to represent. For D, it requires 4 bits to represent. And for D, the occurrence is 5 times. So it requires 5 into 4, yeah, that is 20 bits. And for E, it requires 50 bit and occurrence is only 3 times. So it requires 15 bit. For F, again 5 bits and it is only 2 times. So it requires total 10 bit. Then if we sum all these bits, then we will find out that total 185 bits are required with Huffman coding. Okay, if we have used your SKY coding, you have required 700 bits. If you have used next coding where we require 3 bit for each character, then we require 300 bit. But in case of when we use Huffman coding, we have required only 185 bits to represent all these. In the first ASCII case, the average bit required to represent each character is 7 bit per character because we have total 700 bits and characters are 100. So each character required total 7 bit. In the second case, we have required 3 bit per character, but in the case of Huffman coding, we have required only 1.85 bit per character to represent this complete message. This is your Huffman coding algorithm. Okay. Now, is it clear to you?
Yes, sir.
Is it clear?
Yes.
Okay. This is your Huffman coding. These are two applications of your Huffman coding algorithm. Okay. Now we will check the complexity of this Huffman coding. Okay. What is the complexity of Huffman coding algorithm? I'm sharing a one screen also. Okay. Is it visible? I think now visible.
Yes, sir.
Okay, this is your Huffman algorithm. Okay, in the Huffman algorithm, first we have insert all the values. So the complexity is your order of n, because it is take your order of linear time to store these values. Okay, but every time in Huffman coding, I'm taking the minimum value. It means I'm arranging the elements in the ascending order from minimum to higher. From minimum to high. I'm arranging all the elements from low to high. Every time I'm taking two minimum element, two minimum, two minimum, two minimum. It means I'm sorting all the elements according to their minimum value. Means according to the ascending order, I'm sorting all the elements. So how much time it will take for ascending the order, for ascending the value? It will again take your n log n time in the best case, in the merge sort. So the overall complexity of Huffman coding algorithm will also be your n into log n, the greedy approach. Is it clear?
Yes, sir.
Okay, so this is your Huffman coding. Next application which we will discuss, that is your job scheduling algorithm. That is your job scheduling algorithm. One more application of your Huffman coding algorithm. Okay, and is it visible?
Not yet.
Okay, okay. I think now visible.
Yes, sir.
Now this is your job sequencing algorithm, job scheduling. You can say anything, job sequencing agents. Okay. In the job scheduling algorithm, okay, you have some deadline. Okay. Suppose, think that you are a software engineer, okay, in a company, and you have different jobs, and every job have a deadline, and within that deadline, you have to complete your task by checking that what should be the maximum profit. By considering the maximum profit, you have to complete your task, your job within the time. Okay, so job sequencing, job scheduling algorithms are applied to schedule the jobs on a single processor. These are the assumptions. The processor must be uniprocessor. You cannot say that we have three processors and all these three different processor will execute these three jobs simultaneously. And this is the limitness, that the jobs are executing on a single processor, the uniprocessor system, to maximize the profits. Okay. The greedy approach of the job scheduler said that you have n number of jobs with a starting time and ending time, deadline, and they need to be scheduled in such a way that the maximum profit is received within the maximum deadline. Within the deadline, there should be your maximum profit in this job sequencing. But in job sequencing, you have some assumptions. Because first one is there is single processor system. This is your single processor system, not multiprocessor. And second one is no preemption. You cannot say that one job is preempted and you have executed another job. You cannot preempt any job. If one job is executing, that will be executed completely. After successful execution, another job will be executed. You can't say that you have preempted one job and another job is start to execute. No, that is not possible in job sequencing. Okay, and one more assumption. That is, every job take 1 unit of time. It will take 1 unit of time, every job. Okay, these are the assumptions. With the help of example, you can see that, you can understand more. Here you can see you have four jobs: J1, J2, J3, and J4. You have four jobs. These are your J1, J2, J3, and J4. And each job have their profits and deadline. The deadline may be your month, your week, anything which you want. Okay, suppose this is month. We are considering a month. Okay, job one, J1 has 50 profit, and the deadline of this job is 2 months. Within 2 months, you have to complete this job. Okay, J2, the profit is 15, and within 1 month you have to complete this job. And J3, your profit is 10, and you have to complete this within 2 months. And in the J4, the profit is 25, and you have to complete it within 1 month. Okay, this is your profit and deadline, and these are four jobs. In the first case, you can see that you can compare that which job have maximum profit. You will schedule that job. Now you can see that maximum time is 2 months. So I have maintained a job queue. This is a job queue. Okay. Within 2 months, first month and second month. These are 2 months. Within these 2 months, I have to execute this. Okay. But I have to select those jobs which will give me maximum profit. In the first case, you have just to check that in all the jobs, which job have maximum profit. The job J1 has maximum profit is 50. So you have put J1 job in the first month. Its deadline is within 2 months. Within 2 months, you can execute in both the month, either in first month or second month. The maximum profit is 50. You have put first the job J1 in the first month. Now J1 is here. The profit is 50. Now with for second month, you can check. Now you have only one job left, because the job J2 and J4, their deadline is passed in the first month. You cannot execute the J2 and J4 in the second month. But I have selected job J1 according to the best profit, maximum profit in the first month. In the second month, there is only one job left. That is J3. Sorry, that is J4. No, sorry, that is J3. Here it should be the J3. Okay. In the second month, the profit is 10. So total overall profit is your 60. If I have, if I am greedy about only profit, I have not checked the deadline. Okay. The maximum output is your 60. In the second, what should I do? In the second case, in the greedy approach, in the job scheduling algorithm, in the first step, I find the maximum deadline value from the input set of jobs. Okay, I will find the maximum deadline value. Maximum deadline value is 2 from the input set of jobs. Okay, once the deadline is decided for each job, arrange the jobs in descending order of their profits. I have arranged all the jobs according to descending order of their profits. Okay. In the third step, I have selected the jobs with highest profit. I have selected those jobs with highest profit. This those jobs which have highest profit. I have selected that those jobs. And their time periods. I have selected those jobs with highest profits and their time periods, their deadline, not exceeding the maximum deadline. Okay. And then I have selected the jobs of the output. It means I have arranged all the jobs according to their profit in the descending order. First case, I have checked that job J1 have the maximum profit. But I will also check the deadline. What is the deadline? Deadline is second month. Then I will put this J1 job in its minimum, its maximum deadline place. Maximum deadline place is 2. So I will put this job in the maximum deadline place or nearby maximum deadline place. The maximum deadline is second month or nearby maximum deadline is second month. So I will put this job in the maximum deadline month. So I have put this J1 job in the second month. This J1 job is now in the second month because deadline is sec 2 and I have put it in the maximum deadline time. Okay. Now this J1 job is in the second month. Now I can consider all the three jobs because J2, J3, J4 all can be executed in the first month. This J3 job can also be executed in the first month because its maximum deadline is 2 months. Now I will compare the profit of these three jobs. Now check the maximum profit is J4 25, J4 25. So I will put this J4 value, this J4 job in the first month. Now you can check that the maximum profit I have earned it, that is US 75. So in the job sequencing, at first I will find the maximum deadline value. According to that deadline value, I will maintain a job sequencing queue from the input set of jobs. In the second step, if the deadline is decided, I will arrange all the jobs in the descending order on their profits. Then, in the third step, I will select the jobs with the highest profits and with their deadline. And I will put that job in the maximum deadline time or nearby deadline time. According to this, I will find out the maximum output, the maximum profit in the job sequencing technique, in the job sequencing algorithm. Is it clear to you? The next application of your greedy technique. Is it clear?
Yes, sir.
Okay, okay. Now we will discuss about the time complexity with the help of the program. Okay, I am where is job sequencing program? Okay, I will share on screen also. Okay, there is I think there is not a program. Wait a minute. Okay. Where is the program to the power n? Is it clear? Sorry, is it visible?
Yes.
Job sequencing. I think I have
No,
shared
sir.
it.
No, it is visible.
Okay, okay, it is visible. In this scheduling algorithms, we have used the brute force solution for this problem to generate all the sequences of given set of jobs. You have checked that. We have used hit and trial method in this problem. Every time we have done a comparison according to the profit. I have used a hit and trial method. The simple and brute force solution for this solution is we have checked all the sequence of the given set of jobs to find the most optimal sequence to maximize the profit. Suppose there are n number of jobs, we have total taken 2 to the power n subsets for to check the maximum. Okay, to optimize this, we have sort the jobs in the decreasing order of their profit. We are sorting here, you can see that we are sorting here according to their profit, decreasing order, and we have find out the highest deadline among all the deadlines. We have used a Gantt chart, that is your job sequencing queue. We have used that job sequencing queue there, and we have assigned a time slot to individual jobs. And to pick each job, we have picked each job one by one, one by one, one by one, and we have checked the maximum possible time slot for a job. And because every time deadline is assigned with the job, if it not filled, we again check for the deadline every time. I'm checking the subsets every time. After checking that, we have compared, we have arranged them. For arranging, it will take, obviously, it will take uh, and log and time. But we have checked all the sequences, all the permutations, combinations, all the possible subsets. That will take to your 2 to the power n time because we are checking all this. After that, we can calculate the complexity, every comparisons with this. Okay, so the okay, you can see that. So the complexity of this algorithm is order of n square in the worst case, because we look for all the slots. You can see that all the slots in the Gantt chart for average, because we are looking for every combinations. So it is take your order of n square time in the best and average case, because we have a subset problem. Okay, this is the time complexity of this. So I think it's enough for today. Is there any questions? Is there any questions in
No, sir.
next greedy
Yeah.
approach?
Yes, sir.
Yeah, tell me.
Sir, we are asking about the time, sir. In this time, if someone having job, they cannot attend the class. If 1:30, I think the exact time is good time for us. So
Okay,
today
actually,
was Friday. I think
okay,
three or four students are available right now because this time is for namaz and also going to home. So
okay,
because
okay.
of that, sir.
Okay, okay. Actually, today I have some important meeting. Actually, I am a professor in government organization. Okay. Actually,
Okay,
there
sir.
was a urgent meeting at that time. So yeah, it was only for today. From next time, I will take at the same time. Okay.
Okay, okay, sir. Because of that, sir, the students are
Uh,
absent.
okay. If there is any drastic change in the schedule, I think there will be any urgent meeting. Otherwise, I will be available on the same time. Okay.
Okay, sir. Okay, sir. Thank you.
Excuse me, sir.
Yeah.
Is there any recorded videos for those students, those are absent today? So they want the recorded videos. Is it available in LMS or somewhere to
Uh,
access?
Actually, the regional center will provide the IGNOU Regional Center will provide these videos because these are already recorded. Okay, they will provide it to you. Is
Okay,
it
sir.
Is there any questions regarding this topic?
No, sir.
Okay. Thank you, class. Thank you so much. We will meet again.
Thank you, sir.